What if one platform covered everything from idea to market-ready product? A platform teaching all the AI tech and practices needed for successful AI-driven startups.
This is like AI imagination.
We found that the more specific we are.
We used a classifier, we trained a classifier.
I really wanted it to just be more open-ended for the user.
We were experimenting with different chunk sizes.
Having some problems to something.
By blending cutting-edge technologies from industry giants, you can create revolutionary AI products that drive innovation forward.
This was a special hack, it was a battle.
Let the hacking begin.
Hi everyone, and welcome to the second day of our Gigas AI for Connectivity Hackathon. As promised, we have for you 3 workshops today, and we are going to start with the first one. Without further ado, I would like to ask to the virtual stage Mr. Chandra Shakar, the head of AI at Phoenix Technologies, who will give you a short presentation about Current AI.
Thank you, and have a hi everyone. I'm going to talk about what in general Phoenix Technologies in Switzerland doing, and also some of the AI advancements that the Phoenix Technologies working on. So hi, my name is Chandra. I'm the head of the infrastructure on the Phoenix Technologies, which is kind of working on the AI data centers. So what is Phoenix Technologies? Phoenix Technologies provides a secure, sovereign, enterprise-ready quant AI super system. So I'm going to talk a little bit more about it in details as I move on. So we generally talk about AI, and we tend to use laptops and do a lot of the AI works. And I'm sure you guys could be doing a lot. Now think about the organizations and how they would do it, AI at a scale and for the commercial usage, right? So that's where Phoenix Technologies is doing their best at. So we do provide Swiss AI for commercial usage. That means that, we look forward for enabling the enterprise customers, ensuring that the data is protected. So data sovereignty will be something guaranteed, which means that all the data that being used for those AI models or people who are consuming is strictly prohibited in the Switzerland sovereignty. We also offer confidential AI solutions. The confidential AI solutions are based on the confidential computing capabilities. Essentially, that means that you do a job in a way that nobody can understand or read unless you are the only authorized person to do it so. So with the confidential AI solutions, the enterprise customers can access the AI models and do whatever they wanted to do to their applications in a secure fashion. And the context of each of these data points are preserved and will be only consumed by the user of the application. So Phoenix Technologies also offers solutions of the hybrid cloud, which means that the modern era of the workload deployments on a data center, you could think about the containers, like the technologies of the type of the orchestrations, like Kubernetes, right? All the hybrid cloud solutions are based on the Red Hat OpenShift, which provides the very good enterprise workload deployment like a containers. Also the Phoenix Technologies, the entire solutions are based on the open source, which means that all the deployments that the end customers can do, right, are based on the open source, which means that it's not restricted where the applications that's been deployed on this data center can be migrated elsewhere as well because of the open source technologies. The data centers that we operate at a Phoenix Technologies are very high energy efficient and very cost effective by that because of the less consumption of the energy. So you could see on the right hand side, we operate like three divisions and with the 4 data centers within Switzerland, which are kind of, distributed within the Zurich and the nearby regions to make it the highly, high data center stand-up, basically. So any point in time, if you have any questions, you can feel free to ask me, but I could continue otherwise. So what Phoenix Technologies is working with the industries that, right? So because of the Phoenix Technologies, the kind of, background and the investment into the quantums of the types of the workloads or the AI, the various industries that we are working are the life science or quantum and AI, the kind of, cutting edge technologies that today's world is working with. Of course, like a lot of the digitizations, think of the government entities doing a lot of the digitizations, right? When you wanted to go do some work at the government organizations, you need some things to go and work with. So a lot of the digitizations are happening here. Of course, we also work with some of the partners in the environmental, banking, finance, and the hospitality areas. Okay, now, what is the technologies behind the data centers of the Phoenix, operating, right? So we have the Quant Cloud and then the Quant AI products, and the underlying technologies are based on the Vela AI supercomputer. So Phoenix Technologies partnered with very important people in this, where IBM, for example, and the Red Hat. So with the IBM Vela AI supercomputer, it's kind of imagine like, if you wanted to deploy your AI solutions in an efficient, optimized way and kind of, scalable. So the architecture that needed to have such a magnitude of a scales, you need a better organized infrastructure that could cater the bigger, large AI solutions deployments, and efficiently, you can probably use the hardware underneath and use it for your application developments. So on the right hand side, you could see like, how the data center look like. So this is like a big infrastructure environments where imagine like how the nodes, we call that like, imagine they are like a data center, the virtual machines with the different resources like CPUs, GPUs, and memories and all that, and then storage, and then how together combined with a high-speed network links, right? So this is a design which ensured to operate very, very efficient, right? And also the data center is designed in a way that it is completely protected from accessing elsewhere, and that hence helps with the data sovereignty and the compliance of the laws, that's available in these regions. So also, right, the Vela supercomputer is integrated with the Red Hat OpenShift, and by doing that, you could leverage, for example, Watson X or Red Hat OpenShift capabilities to kind of, train your model or fine tune your model or deploy your model for your application usages. Since Red Hat OpenShift is, kind of a leader in a way, you could orchestrate the containerized workloads. So hand in hand, put together OpenShift plus the Watson X along with Red Hat OpenShift AI. It's a seamless, efficient environment for the end users or the customers here. As I was saying, the Vela supercomputer also enables the open source AI model deployments. Imagine a Llama or Mistral or any other open source AI models. You could go and deploy them on watsonx platform, which is kind of built with the trust, and then the performance of the open source AI models automatically optimized because of the data center architecture. So now think about the bigger organizations. And nowadays, a lot of the stuffs where many people go, talk to ChatGPT with their questions, right? But imagine it's not that simple when it comes to the organizations where you cannot put some of your data into the ChatGPT because ChatGPT is kind of consuming some of this data, and probably organizations will have the kind of sensitive informations with them, and which probably you as an employee wish not to share it with somebody like a third party vendors, right? So you have to make sure that when you are doing some of these things, we have to ensure the data protection is always there while you wanted to probably provide some of this information to your AI solutions, but process in a way that the data is kind of secure and safe. So what we are trying to look is here, you could see Meet the Quant AI Concierge. So this is a solution that Phoenix Technologies is investing and working a lot. And the solution is based purely on the confidential computing. So any of the data, right, that comes to these solutions is safe. One is like, how the data is safe in general, right? So you wanted to make sure that any of the data that comes in is encrypted. And when it is really processed within the applications, you wanted that to be encrypted. And then when you are storing the data, you wanted to then encrypt the data and store the data. In general, many of the industry solutions probably help with the, the data kind of, inbound or outbound could be encrypted, but storing also encrypted. But many of the solutions in industry is not compliant, where even while you are processing the data, you need to make sure that data is encrypted, because imagine there could be possibility that you could take the memory of
I'm very sorry, we have some technical issues currently. We're waiting for the speaker to get back the internet connection. So please stay with us. We'll be back very, very soon. Hacking productivity.
Hi, I'm back. Sorry for the interruption. So let me quickly recap what I was talking about. So we at Phoenix Technologies are working on Quant AI Concierge. The concierge is developed in a way that the data in flight or the data in processing for the applications or data at rest is completely encrypted. So we are ensuring that the data that flows across these applications is completely safe and secure. And the users who are trying to access and the data that the user provided is only accessible to him. Let's imagine this application being consumed, let's say even in one organization by the different people. So every person has their own contextual data. So when you ask the AI assistant a question, the answer could be varied because of the data context that each individual data owned by the users. So in a way that we are developing very safe, secure, encrypted AI assistant, which is exactly like a chatgpt because underneath it uses the open source models like llama 3.3 or any other open source models, right? So you could have AI concierge assistant, which is like a chatgpt, but completely end-to-end secured in a way that the data is not being shared or not being even explicitly shared among the users even using this particular assistant. So it leverages the confidential computing even at the hardware capabilities levels to ensure that it's a level 4 standards in terms of the encryptions across all the components that's been deployed here. So now you could try the Quant AI Concierge that's available, right? So I'm sure that you might have already the document. So you could click on the access to the Quant AI Concierge link shared here. Then you could see some screen like this. So you could ask questions, or you could do like a file uploads and then ask anything you want within that file, and you could expect some answers from Quant AI. So it's kind of almost equivalent to ChatGPT with a lower capacity, by the way, for this, but you could probably get something of the type of the answers that you could hear from it. But it's kind of safe and secure. Also, we from the Phoenix Technologies deployed the different models. Just give me 1 second. Okay, we at the Phoenix Technologies deployed different open source AI models for your consumptions here to play with. So we do have llama 3.3 70 billion model that's been deployed, and the inference endpoint is accessible with this link. Here I also given some details on how you could consume these models. For example, the LLama 3.370 billion model is deployed on a VLLM serving runtime with the OpenAI standards, which means that you do have the REST API calls of the various types that I listed on the left-hand side, and you can make a queries. So you can click for more of the documentation help if you need from the link that I shared here, which could kind of, the API reference to the OpenAI documentation. How do you use this model? Just for a simple one call explanation. So you can export the API key that is needed in order to hit this inference endpoint, because it's kind of a behind with the configured with the secret key. So here on the down, I shared the OpenAI key for this model. So LLama 370 billion model, I shared the OpenAPI key here. So all you need is export that OpenAPI key of this and then make a call command. Here, for example, this is the OpenAI chat completion query. And this query is talking like, what is AI, right? So you should be able to hit back with the answer. Then you know that the model inference endpoint would be working for you. And then you could leverage the other API calls that are available here and probably reference the documentation of the OpenAPI standards. Similarly, I deployed the multilingual embeddings model. If you think that you would need some embeddings model for your usage, this is the E5L large model. And then again, right, so it has its own API key. So you have to export this API key. And then you could probably, for example, here, I given embeddings as an example. And you could probably provide an input. Then you could hit back with the embeddings information as a response with the encoded details. Similarly, I also deployed the Microsoft PHI4 model, and this is also deployed on the VLLM runtime. So you could feel free to go and consume this. With that, I conclude my session. Where what I would like to present, and then the resources are the materials that you could use for your hackathon. I wish you all the very best with your hackathon. And I'm happy to hear any questions you have for me and answer.
Okay, there's no questions either from the chat or live audience. So thank you very much again for amazing presentation. And now please give us a minute to prepare the setup for the next workshop, and we will be back in a second. Welcome back. We are here to start the second workshop of today, and I would like to ask to the stage Ivan Dotu, Applied Science Lead at Giga, who is going to give you the workshop titled AI in Giga. Welcome, Ivan. Go.
It's not showing the desktop that I'm at. No, it's in a different. Hi everyone. Thank you. Thank you for being here. Thank you for being online and on site. I'm on site and it's not a recorded video, so I might move a little bit. Hopefully you won't lose me, those of you who are online. The talk or the workshop was AI in Giga. This is not that I changed the topic, but I'm just gonna talk about AI in Giga through this presentation. And it's basically a summary of what we do at the applied science team at Giga. Let me know at any time if you have questions. You can stop me. And in the meantime, I'll keep going. I'll try to be fast since we're running a bit late. I'm just going to go very quickly through three things. First, some resources, not necessarily AI related. Some of them, yes, but they're foundations for us to later use AI in different forms. And then the main tracks that we work on, some of them, we've been working on them for a long time. Some of them we just started. Some of them we're basically about to start, but they're planned. And some exploratory work that we're doing or considering that basically doesn't fit into any of the tracks. So let me talk about the core resources very briefly. One thing that might be interesting for the hackathon and for you hackers is that we're building a database and a code repository that will be open source once it's finished. And it's basically trying to gather some of the geospatial data sets that we use typically around schools. And we use them for many things that you'll see later in the tracks. But basically what we want is not the database itself, but the structure that we're building. We think it's a good strategy to build the database like that and have these views, which are contextual aggregations of these data sets around schools, but also inside tiles in the country and at administrative regions, and extendable, of course, to other points of interest, not only schools. And so all the code that we're using to download, process, handle all this structure is what we call GeoDB repo. And as I said, it'll be open source soon. And hopefully at least part of it will be available for hackers in the next hackathon. And along with this, we're also doing a library that we call GigaML Utils. This is basically for doing what I call classic machine learning. And it's just, putting together a lot of things that come from other libraries, but in an effort mostly to get people started quicker and easily, and also to set up some sort of Giga standards on what we do. And finally, a visualization tool that we're calling GigaTiles. This is not GigaMaps, which, Nara, as a surprise, will give you a quick tour right after me. This is just a visualization tool for the database that I spoke about, that we can use to quickly visualize the data sets that you have, how are they looking, and compare them to the school locations and things like that. That will also be open source, the code for it. And the idea here is that all these things are open source. We're not selling them as a product, but we're selling them as a way of doing things where the code is here and you can use it, expand it, or adapt it to your needs. And I'm going to go quickly through the tracks. The main track that you must have heard about is AI mapping. Basically, what we do is AI school mapping, but we're extending to other points of interest like health centers. So I just put it as AI mapping. And what we do is basically use high-resolution satellite imagery to predict candidate points of interest. I'm going to talk about schools, but the idea is the same for other types of buildings, like, as I said, like health centers. And the approach that we take for doing that is to model this as an image classification problem and use deep learning to predict candidate school locations in a country, given, obviously, known school locations and known non-school locations in that country. You might think, why image classification versus object detection? We've used object detection previously. We feel like at this point we're more comfortable doing image classification and sort of getting to object detection by leveraging GradCam techniques to better pinpoint the location within the bigger tile that's classified as a school. And we're also not AI related per se, but in practical terms, we're developing a tool that we're calling Giga Validate that's going to help stakeholders validate the predictions that we do remotely or on the ground. Yes. So the problem that we're solving here, basically formally, is given a set of satellite images that contain schools and a set of satellite images that do not contain schools. And here you can think that these are restaurants, churches, police stations, so not just desert versus a building, right? So given those two data sets, we want to be able to predict school locations in places where we don't know that there's a school, right? Is that answering? Sure. Okay, cool. So what we do for that, as I said, with this data set of school versus no school high resolution satellite images, what we do is we train a deep learning model in the traditional, validation, test, train, test, validate setup. And then what we do is basically we download satellite images for a particular country, and then we do prediction on those images with the trained model for that country. We also do regional models for like bigger regions, but that's the approach that we've been taking most recently. And that's just a snapshot of this tool that I told you about, GigaValidate. That basically is going to show the predictions and what's known for the schools and try to find new schools or autocorrect some of the locations that might be slightly off using this. So that's one track. The other track, I'm just going to call it infrastructure planning, but here we're looking really at the computational problem of connecting schools with different technologies. And formally, this is an interesting problem because this is a combinatorial optimization problem, and in which what we want to know is how to connect schools, minimizing the cost of this connectivity. So if you just look at connecting schools with fiber, that with the objective to minimizing the cost of this connectivity, which mostly relates to minimizing the kilometers of fiber runs that you have to have. That actually it's an NP-hard problem that reduces to statement tree problem. And for that, we use combinatorial optimization techniques like constraint programming, SAT, and meta-heuristics. And the bonus here is that this is just for fiber, but if you try taking into account that it could be fiber, or it could be microwave, or it could be mobile, satellite, then it just increases the difficulty, not the other way around. Still the same type of complexity, but just more combinatorial explosion. And that's I'm just showing here in case anyone is more interested in this. The complexity, and I'm just talking about fiber, comes from the fact that, one, you cannot just connect everything. You have a fixed length that you can do at most. And from the fact that if you were to do it just by running a straight fiber run from one school to the other, and again, so sorry, for the first time, this comes from the fact that you're using, let's say, economies of scale, right? That you're connecting a school and then you've brought the fiber to there, so from there you can connect another school, right? If you were able to do that just like on a straight line, then that's actually a simple problem. It's minimum spanning tree problem, that it's not, that's polynomial. But once you go into a more realistic scenario in which typically the fiber would run parallel to roads, and that's how you basically use your country road system to do the fiber runs, then you can imagine that you're going to have splits at some point, kind of forks on the road. And that specific thing makes that this problem is no more a minimum statement tree problem, a minimum spanning tree problem, but it's a statement tree problem, and that makes it NP-hard. So these two things we've been working for a while. The next tracks we are starting, one is quality of service. We're getting this data from upload speed, download speed, latency, so forth, from schools connected to the internet. And there's a set of questions that we want to answer. One of them is trying to predict from this data the underlying technology in which the school was connected, detect anomalies, predict connectivity outages. And that's basically combining classic machine learning techniques with time series data analysis. The next track, I'm going to be a bit faster because these are things that we're just starting to do. It's procurement. There's several problems that we're facing in procurement, such as predicting the number of schools when we have no idea about data in that country, and estimating whether some of the schools are connected or not, whether they have electricity or not. You can see that these are mostly things that have been solved with classic machine learning techniques like random forest, boost trees and things like that. So for that type of work, you can see directly that GigaGeoDB and GigaML utils is going to be very important to help someone working on this get started quickly and advance quickly. Similar thing with social sciences. That's basically the same sort of problems if you think of what you're trying to do. You're estimating, you're trying to predict, but for advocacy, basically. and questions that we want to answer is what is the impact of school connectivity in education outcomes? What is the impact of having or not having very correct geolocation data for your schools in GDP and the development of a country? And we envision that we're going to start using not only classical machine learning techniques, but sometimes statistic, probabilistic methods, and potentially probabilistic graphical models. And now for exploratory, very quickly, we're starting to delve in climate and emergencies. Climate also as advocacy, and climate emergencies as emergency response. Quantum computing, we've been looking into how quantum computing can have an impact into complexity theory and solving combinatorial optimization problems, but also in quantum internet, since what we're doing is connecting schools to the internet. And finally, we've also started to look into creating RAG systems for us, so using retrieval augmented generation for applications that we have internally, sometimes for procurement, sometimes for HR, sometimes for comms, just to be able to look at all the documents that all the teams at Giga have done and try to come up with like a byline for something. So basically a sort of chat box with specific uses. And very quickly, I'm giving you here a slide with a sort of matching of track and AI technology used. And I think with this, I'll try not to bore you anymore, just to ask you to join us on our Discord. And thank you for listening. And before we go, I'm going to give the floor to
Silly question, but when you say connectivity between the schools, so your objective is to connect the one school to the another school, or the school to connect to the telecom operator so that they have a internet access?
So we're talking about the fiber.
Yes.
Yeah. So the objective is to connect all the schools. The issue is that if you need to extend the fiber to connect that school, then let's say there's a fiber node here and you're extending the fiber so it reaches this school. Then when you have another school here, you're not going to start your fiber run from the fiber node all the way to that school because you already have fiber getting to that school. So it's not like you're connecting one school to connect another one. Is that of course, if you bring the fiber here, then that it's closer to that other school that you wanted to connect.
Okay, so you're not basically connecting that school with the fiber to some kind of a telecom operator which gives the internet access so that it can now have access to all the school. Is it like this?
Yes, it's sort of like, in a sense, it's like you're planning the middle mile, assuming that the fiber is there and there's gonna be like the last, really last mile, like that there's an access point here now that school can be connected, and let's move to the next one.
All right, thank you. And regarding the RAG, it is accessible to all schools?
No, RAG is we're working. So RAG, the retrieval augmented.
Yes.
That's for us at Giga for now, and we don't have it yet. But that's something that, since Giga has been on for 6 years almost, we've generated such an amount of documents. All the teams.
Okay.
That for some applications, like for comms, when they want to say, what did we do in this case? Can we have a use case? It'll be a very useful tool for them to be able to sort of scan through all these documents and be able to come up with something that speaks to the stakeholders.
You. That's really wonderful things you're doing.
Thank you.
Okay, we have one more question from the audience.
Hello, did you try reinforcement learning for the image classifier?
We have not. We have not, and I personally think reinforcement learning is interesting more for optimization. Actually, I would say for combinatorial optimization problems in which there's not a lot of structure in the problem, or you don't know that structure. and you have the result, right? So it's like imagining the fiber path thing where if you didn't know how the connectivity, like there's a straight line or a road, you do something and have a cost and learn from that. That would be your reward at the end of the day, and then you'll try to do things. For schools, it's a bit more different than that because we clearly have a data set.
Yeah, the way I was thinking about it would be more like with human feedback, where you will make, like, if the model is not extremely sure about put it as like it's on its borderline, you could ask a human for feedback. But I think there's a school there. What do you think?
Yeah, so we've looked into doing this human in the loop type of learning. It just requires a lot of human resources to do that. So I think we're yet to see and start like really validating the predictions that we have on the ground. We've done validations for several countries, many cases through crowdsourcing, and we've shared this with countries, but I don't think we have a clear sense of how well, let's say, like how realistic are the predictions really on the ground. And I think answering that might tell us we need to do something more on that front, or, you know, like the Giga Validate tool is enough because we're like really, really close anyways to the reality.
Yeah, that makes sense.
Right, thank you very much.
All right, let's try to do that bonus.
Great. I'll be very quick, but based on some questions that we got, should I go ahead? Yeah. From the audience, we thought that would be helpful to very quickly introduce and show you the main data and data sets that Giga works with together with the main product that we have for that. So I'll quickly do that because I know that we are also running over time.
Let me just do it here. Don't have control.
Maps.
No, it's just Bing sucks. Well,
Big part of it, make it a bit bigger, of the things that Ivan talked about and the work that we do, it's built on top of this map. This is the very first thing that Giga produces or generates for a given country. And it's basically a global public map of school locations and their connectivity status. We use this as foundation to understand the problem in a given country, how many schools there are, how many of them need to be connected, where they are, so that then we can use this information to inform the types of connectivity solutions, optimize for cost, optimize also for quality, and also eventually use it for monitoring. You could also think about use cases of this map where you could start doing the load balancing, optimization of traffic, so that with less we can reach more schools. Every dot that you see in this map, it's a school, and they are colored based on their connectivity status. Red dots are unconnected schools, and green dots are the ones that have access to the internet. And this map doesn't only show you access to internet, it's also a map of inequity or poverty, because you can clearly see, for example, here in Brazil, that the Amazonas region, that's the poorest region in the country, it's the one that's red. Whereas richer areas or wealthier areas like Rio de Janeiro, Sao Paulo, they are mostly green and connected to the internet with higher speeds. Another interesting thing, and then I'll go to the API and to the data itself, but another interesting thing of this map, it's that it gets updated in real time. We have real-time data for around 100,000 schools, and that means that every 2 to 4 times a day, we get information about the quality of the connection, upload speed, download speed, latency. Those are all the schools that are blinking in the map. So if you see a school that's glowing, it means that that school is transmitting information live, and you are able to understand that. And here you are able to compare. So maybe if I go to the school page, you can click on a school, you come to the school, and here in the left, you can see the graph and how the speed has changed over time. This is the minimum that the Brazilian government had set for these schools. And then here you can see what's the actual speed they are getting, and means that this school is performing well. This is the average download, but you can also look into latency and other metrics and measurements. So maybe, for example, if you go to the one that's glowing in orange, if I click here, and if I go to this school, here you'll see that the speed is below the threshold that has been set. So that's why it's orange. And then the ones that are in blue, blinking in blue, we are not getting any measurement today. So we don't know whether internet is working or not. Here you can see that the measurements are not as consistent. Another thing or other data that you have here as well, you can change this for other types of information, such as distance to fiber, for example. So here you can see which schools, no, here I don't think we have that information for this particular country, or coverage. So you can see whether this school is in a region that has mobile coverage or not. Is it 4G, 3G, 2G, and the same how far it is from an access point. So again, you got to start using this information to plan for network deployments and optimize how to do that more efficiently. And maybe I'll go now to another country, such as Sierra Leone, to show you the difference from one country to another country. You saw that in Brazil, is there a question? Yeah. I'll finish in a second. I'll just show this and then I'll show the API and then we can get some questions. So this is the case of Sierra Leone. I mentioned it yesterday, but here there are only around 200 schools out of 11,000 connected. They are all in the capital. You can see them here. But basically the entire country, it's red. However, if you look into mobile coverage, you click here and you look into mobile coverage, you see that there are many schools that have 4G. That means that there is no real reason for these schools not to be connected, and that it should be fairly easy and straightforward to put a 4G router with a SIM card and just get them connected. So yeah, this is a map. This data, most of this data, not all of it, but most of it is available for all of you during this week. If you come here, well, and actually I think they all should be in the resource list that we shared with you, but otherwise, yeah, here you can explore the different APIs that we have. There are some that are public, such as the location of the school, etc., and then some others that require a key. We haven't launched it fully yet. We are testing it out. But for the hackathon, we've uploaded CSV files with this data so that you can use it as well. Yeah, that's it. I don't know if there are any questions. All good? Perfect. So I believe with that, Joanna, hope.
All right, thank you very much for today's workshops. Please remember that the stream was recorded, and if you would like to rewatch it, you can find it on our Twitch and YouTube channel. Please remember that we have one more workshop today. It starts at 5 p.m. Central European Time, so don't miss out. And yes, I hope that it was very useful for you, and we see each other on the next workshop today. Bye, everyone.